Hello friends, welcome to Learner's Planet. Friends, this is our 7th session of Geometry Workshop. We have discussed good number of problems, concepts, theorems on geometry, right? In this session, I'll be discussing some more problems and you have your paper and pen with you and just give a final touch to your preparation with these workshops. Okay, so let's begin this session. Now let's start this problem. Here ABE is a triangle and various other dimensions are given AC, AD, CD, BC, DE. We have to find out the area of this triangle ABE, right? Now, how do we do that? See here, ACD is an equilateral triangle because this is 8 and this is 8, right? Now, what is the area of an equilateral triangle? That is root 3 by 4 side square, right? So, root 3 by 4 into 8 into 8. That is the area of this equilateral triangle. So, that's actually 16 root 3. Now, this is the area of CAD, right? BAE and CAD, in both the cases the length of the altitude is same, right? Because this is the another parallel. So both the triangles are between the same parallels. So altitude will be same definitely. The only difference is their length of their bases. For triangle ACD, the length of the base is 8. For triangle ABE, the length is 8 and 3, 11 and 1, 12. Right? Now base length is getting 3 by 2 times. That means, and altitude is same in both the cases. That means area will also be 3 by 2 times the area of ACD. Getting my point? Once again, altitude is same of triangle ACD and ABE. The difference is between their bases. In the case of ACD, the base is 8. In case of ABE, the base is 12. That means base of ABE is 3 by 2 base of CD. Altitude is same. That means area will also be 3 by 2 times of area of ACD. So area of ACD is 16 root 3. So 3 by 2 of that. So that's 24 root 3. That will be the area of ABE. A very simple concept has been used over here. No much paperwork is required. No, not many calculation is there, and very easy to understand, easy to do, right? So area of triangle ABE is 24 root 3. Okay. Now in this problem, a boy wishes to tie cable on the top of pillar AB in his garden, and given that CD is equal to 9 meter, AB is equal to 5 meter and BD is equal to 3 meter. Find the length of the cable AC, and also if A is perpendicular to DC and EN is perpendicular on AC, we have to find out the ratio of areas of triangle ENC and AEC, I'm sorry. So let's try this. Now what? This is 5, so this must be 5. Now this total length is 5, that means the 9, that means this length must be 4. Now this 5, this 5, this is 3, that means this is 3. That means if this is 3, this is 4, this length must be 5. Now we have to find out the length of this altitude x. Now once again, this is a right angle triangle and these are two right angle triangles inside it. All the three triangles will be similar to each other, right? I assume this length to be y, right? Now this small triangle NCE and the bigger triangle AEC, they are similar to each other. So I put up the sides in the proportion. So opposite to 90 degree over here in the small triangle is 4. Opposite to 90 degree it is 5. The side opposite to common angle is x. The side opposite to common angle is 3. And the third side is 4x. The third side is y. And here it is 5, 3. So it's 4. Okay. So from these two, x is equal to 12 by 5. And from these two, y is equal to 16 by 5. Now let's find out the ratio of areas of triangle ENC and triangle ABC. ENC, that's half base into altitude, that is half of x into y. So that's 12 by 5 into 16 by 5 and half of that, right? And divide by triangle ABC. So that's 4 into 3 and into half. So I just take 4 into 3 only. So 4 into 3, that's 12. So precisely we are left with 16 by 25. That is the ratio of areas of ENC and ABC. Okay. So we got both the things. AC is 5 and the ratio of their areas is 16 is to 25. Right. The simple property of similar triangles we have used over here, right? And good number of problems based on this property, that is this right angle, and the original right angle, all of them are similar to each other. We have used so many times. Okay, I hope you are clear. Now in this problem, these two circles are intersecting each other at point A and B. XAC and XBD are given straight lines, and angle AXB is 75 degree. That means this angle is 75 degree. We have to find out angle ACB. ACB, right? I join B and C. So this angle we have to find out. Now figures look complicated, but this figure looks complicated, but this problem is very easy to solve. See, from this segment, this angle is 75 degree. That means this angle, that means this angle, that will be 150 degree. From the same segment, the angle at the circumference is half than that of the angle at the center. So this you can say BOA. AO is a straight line, OB is a straight line, so angle between these two will be 75 degree. Just forget this circle, just concentrate upon AO and OB, right? So if this angle is 75 degree, this will be 150 degree, right? So we got this angle. Now forget the smaller circle, concentrate upon the bigger circle. A, C, O and B. All the 4 points are on this circle, on the bigger circle, A, C, B and O, right? If all the 4 points are on the circle, then OACB will be a cyclic quadrilateral, and if it is a cyclic quadrilateral, this opposite angle sum is 180 degree. So this plus this must be 180 degree because this is opposite to this, right? So if this is 150, this must be 30. That's we have to find out. Okay, it's very clear, very simple, looks complicated, but it's very easy to solve. Okay, now we have this problem. We have a triangle XYZ. The sides are XYZ. Values of these sides are given in the m square, n square, y is to mn, and z is this. We have to find out this angle. Right? Now whenever the three sides are given, you can use cosine formula very easily, right? Because cosine formula gives the relationship among sides, right? One angle is included and all the three sides are included in cosine formula, right? Since we have to find out the angle z, I'll be taking cos z. Right? Now cos z over here will be x square plus y square. I write down the formula over here, but you must be knowing the formula and save time to write this in your exams. So x square plus y square minus z square upon 2xy. This is the cosine formula for cos z over here, right? Sum of this minus sum of this, that is opposite to this angle that we have to find out, and product of this into this 2 times, right? But do not write the formula in the time of your exam to save time. Okay, now x square, I put up the value, that's m square, m4 plus n4. You can visualize the same, or if you wish you can write it also. That's m4 plus n4 minus 2 m square, right? And this is 2 m square n square, and this is m4 plus n4 plus 2 m square n square. So minus 2 m square n square, and here it will be minus 2 m square n square. So in all minus 4 times m square n square, and y square is 4 square, 4 times m square n square, so it will be cancelled. I just write for you, it's m4 plus n4 minus 2 m square n square plus 4m square minus m4 minus n4 minus 2m square by 2x square, right? Now everything is getting cancelled. That means cos z is 0. Now that doesn't mean this angle is 0. It's cos z is 0, right? So when z is 90, it will be 0 because cos 90 is 0. That means cos 90 is cos z. That means z is 90 degree. Okay, so do not get confused if you are getting cos z as 0, because if this angle is 0, it will not be a triangle, right? So there is a difference between z is 0 and cos z is 0. Okay, I hope you are clear. So very easily you can solve this problem if you are clear with the sine formula, cosine formula, right? Now let's see this problem. In the figure given below, radius of the circle with center C1 is equal to 2 into radius of the circle with center C2 is equal to 1 by 3, C1, C2 is equal to x. So find PQ where PQ is perpendicular to PC1 and QC2. Now what I do, I match C1 and C2. That means I join C1 and C2. I join C1 and P. So this is the figure that I'm going to have finally, right? Now this angle must be 90 degree. It's already given, and this is also 90 degree. I assume this point of intersection is O, right? Now what is given? Radius of the circle with center C1 is equal to 2 into radius of the circle with C2 is equal to 1 upon 3, C1, C2 is equal to x. That means radius of the circle with center C1 is x. So that's x, and that is 2 into radius of the circle with center C2. That means this is x by 2, and that is equal to 1 upon 3 C1 C2, right? That means C1 C2 is 1 upon 3 C1 C2 is x. That means C1 C2 is 3x. So C1 C2 is 3x. That means this complete length is 3x, right? Now what? Just concentrate upon two triangles OC1P and OQC2. Now these two triangles are similar to each other. This angle is 90 degree, 90 degree. This is vertically opposite angle, so AA similarity is there, right? If the two triangles are similar, the sides will be in proportion. So if this is x, this is x by 2. That means each side of OQC2 will be half than that of OPC1, right? Now this complete C1 C2 is actually 3x. That means this must be 2x and this must be x, right? The same ratio, 1:2 ratio. Now in this case, triangle OPC1, we are having this length, we are having this length, so we can calculate OP, that is 4x square minus x square, 3x square, or we can say root 3x. Now OP will be double of OQ. So OQ is root 3 by 2x. Okay. Now we have to find out the length of PQ. So PQ will be what? PO plus OQ, or we can say root 3x plus root 3 by 2x. Root 3x you can take as common, then 1 plus 1 by 2, that's 3 by 2. So that is 3 root 3x by 2, that is length PQ. Simple concept we have used, not much paperwork is required, and easily you can solve this problem in less than a minute, right? Concept of similarity we use lot of times, you might have observed that, so that's actually important. You need to be clear with the concept of similarity. You should be knowing how to compare the sides, how to take the sides in proportions and all that. Okay. Now let's try this problem. Here in the given figure, BA is parallel to CD. That means it is a trapezium precisely. BA is angle DAC. DAC, that means this angle is equal to angle ABC, this angle. Both the angles are equal. And AB is equal to 10 centimeter. BC is 9 and AC is 15 centimeter. What is the length of AD? Now since AB is parallel to CD, that means this angle will be equal to this angle, right? Alternate opposite angle. Now this angle is equal to this angle and this angle is equal to this angle. That means triangle ABC is similar to triangle ACD, right? It is AA similarity because two angles are equal. If two angles are equal, obviously the third angle will also be equal. So we say it AA similarity, that is angle similarity, right? So this angle is equal to this angle being alternate angle, and this is already given, right? Now if the two triangles are similar, we can compare their sides. Now how do we compare? Opposite to this is y, opposite to this is 15. In this triangle, opposite to this is x. In this triangle, opposite to this is 9. And the third side in this triangle is 15, and the third side in this triangle is 10. Now what we have to find out? Length of AD. Length of AD is what? X. So x is what? 15 into 9 by 10. So that's 13.5 centimeter, right? Simple concept of similar triangles we have used over here. Okay. Now let's try this problem. Here, given a circle with center O, CD passes through O, and given that CE is equal to AO. So since O is the center, OA must be radius of the circle, and OB is also radius of the circle. Do not go to the diagram because it is not drawn to the scale. So OA is equal to OB. Both of them are same because O is the center of this bigger circle, right? Now it is telling CE is equal to AO. So OA is R, that means CE is also R, right? The ratio of area of triangle CED to that of triangle AOB is KS1. Precisely, we have to find out the ratio of areas of CED and AOB, right? Now, area of triangle AOB is what? Half base into altitude. So we can say half R square, right? That's half R square. Area of this triangle, see this complete length CD is diameter obviously. So this complete length is 2R. So this length will be 4R square minus R square, that means 3R square, or we can say root 3R. Now area of this triangle will be half of base into altitude. So half and half is cancelled. Base into altitude, that is R into root 3R. So this ratio is what? Root 3 is to 1. That means K is what? Root 3. Okay. I hope you are clear. Now let's try this problem. In the given triangle ABC, D is the midpoint of side BC such that angle ADB is an acute and segment AE is perpendicular to segment BC. AE is equal to DE is equal to BE. That means these three lengths are equal. So I suppose this is X, this is X. Now D is the midpoint. That means DC must be 2X. And this length is also X. We have to find out AC by BD. AC by BD. BD we already know. That's 2X. AC we have to find out. So see in this triangle, this is X and this is 3X. From here, this point to this point. Right? So we can calculate the length of AC, that is 3x square plus x square, 4x square. I'm sorry, 2x square, that means 4x square, and 2x plus 3x, 3x whole square, that means 9x square plus x square, 10x square, that means x root 10. Okay, just write it over here. 3x square plus x square. So it will be 9x square plus x square. So that's x root 10. So what will be AC by BD? X root 10 by 2x. So that's root 10 by 2. Okay. Or we can say 10 by 4 or root of 2.5. Whatever. Okay. I hope you are clear. Now here PQRSTU is a hexagon, that's a regular hexagon. We have to find out the ratio of area of hexagon to that of PQST, right? Now listen to me carefully, we hardly need any paperwork over here. See, if I put a dot over here and suppose this is O. So OPQ, that will be an equilateral triangle. OSR, that will be an equilateral triangle. Similarly OTU. So precisely a hexagon is a combination of 6 equilateral triangles, right? Which each with each vertex. If we join, we'll be getting 6 equilateral triangles. Now assume the area of each equilateral triangle is 1 unit. That means the total area of this hexagon is 6 unit. Right? Now we have to find out the area of this PQST. Now if just see carefully, this will be one equilateral triangle. Now from this equilateral triangle, in this particular rectangle, if we talk about, this portion is not there. That is actually half of one equilateral triangle, right? This is also half of one equilateral triangle. So precisely this equal to this TPU is equal to one equilateral triangle. This is half, this is half. Similarly here, this is half, this is half. So precisely from the entire rectangle, only 2 equilateral triangles are deleted to get PQST, right? So 2 equilateral triangle, area of each equilateral triangle is 1 unit. So it is 2 unit. So remaining PQST will be having 6 minus 2, 4 unit. Okay, so this ratio is what? 3:2, right? So only concept is required over here, and no paperwork is required, and easily you can do this problem in less than 30 seconds. Okay. Now let's try this problem. Here ABGF is a parallelogram that's given to us, and BF is parallel to CE, and AB is to BD is given to us as 2:3, right? So this is suppose 2x, and from this point to this point suppose 3x, right? Now friends, to solve this problem, once again there is hardly any paperwork required. The only thing that is required is the knowledge of basic theorem, right? Here we will be using basic proportionality theorem. I just give you an idea. For a triangle, suppose this A, B, C, suppose PQ. Now if PQ is parallel to BC, not necessary that P is midpoint and Q is the midpoint of AC and P is midpoint of AB. It's not necessary, but these two, if they are parallel, then AP by PB is equal to AQ by QC. AP by PB is equal to AQ by QC. That is basic proportionality theorem. So that we are going to use over here, right? Now you can see this triangle AFD. Triangle AFD, right? Here AF is parallel to BG because ABFG is a parallelogram. So just concentrate. AF is parallel to BG. That means DB by BA is equal to DE by EF, right? DB by BA is equal to DE by EF. Now DB by DA is what? 3:2. So this will also be in the ratio 3:2, but the constant may be different. Okay, be very careful. Even if I'm using X over here, it's not necessary to be X. So I take it as 3K and it is 2K, right? I write DB by BA is equal to DE by EF, right? So that is 3K is to 2K. Okay, AE is parallel to BE. Just concentrate on this triangle DFA. Okay. Now bring your concentration over here. Now FBD, triangle FBD, right? Here also EC is parallel to BF, right? So DE will by EF will be equal to DC by DB. Triangle DFB, listen to me carefully. DE by EF, because this EC is parallel to FB. This line and this line is parallel. So DE by EF is equal to DC by CB. So DC by CB will also be in the ratio 3:2. Not necessarily K will be the HCF, but DC by CB will be in the ratio 3:2. So I assume this is 3y and this is 2y, right? Now what we have to do? We have to find out AB is to BC, right? Now AB is with us in the terms of X. So if we can find out BC in terms of x, we can find out the ratio easily, right? Now BC is actually 2/5 of BD, isn't it? Because it is ratio 2y and 3y. So 2/5 of BD. BC is 2/5 of BD, and BD is what? 3x. So BC will be 2/5 of 3x. So that's BC. What is AB? 2x. So I write 2x over here. I am finding out BC by AB. I will reverse that afterwards. X and x is cancelled, and this 2 and this 2 is cancelled. So it's 3:5. That is BC by AB. So AB by BC will be 5/3. Okay, pretty simple. Only the use of basic proportionality theorem I have done over here. See, after conceptual clarity, you don't have to write all these things, right? You directly fill up the table over here as I have done, right? This entire work is not at all required. That is for just your reference, what I'm, why and what I'm doing over here, right? After that, if you are conceptually clear, just write down the data like this. Immediately you'll be getting the answer. Okay. Now this is a very simple problem with us. Here, triangle ADC, AD is equal to AB is equal to DC. AD is equal to AB is equal to DC. Find major angle ABD. ABD. This we have to find out. I suppose this to be X, right? Now this side is equal to this side. So if it is X, it has to be X, right? Now what? This is X, this is X. That means this must be 180 minus 2X. So this will be 180 minus 2x, and since this is equal to this, so in triangle ADC this will also be 180 minus 2x. So 180 minus 2x for 2 times plus 33 plus x, that should be equal to 180. Okay, for entire triangle, sum of all the 3 angles, x plus 33 plus this angle plus this angle. Okay, and what we have to do, we have to find out the value of x. That can be easily done now. Only x is the variable with us, so that can be solved very easily. 180 and plus 33 is equal to minus 4x plus x, so that's 3x. That means x is equal to 71 degree, right? Now see this problem. We have already tried this sort of problems earlier in this session. The figure given below is a regular hexagon. Angle AOF is 90 degree. AO is parallel to BX. What is the ratio of area of hexagon to area of rectangle ABXO, right? See, the entire hexagon is the combination of 6 equilateral triangles, right? So if I assume the area of each triangle is 1 unit, that means 3 unit will be consumed below X line CF, right? Because this is half of the hexagon, right? So 3 unit it's there, and from the remaining 3 units you can see once again this maybe this is the center of this hexagon. PAF is one equilateral triangle and PBC will be another equilateral triangle, right? So this is half of one equilateral triangle and this is also half of one equilateral triangle, right? So from the 3 over here, one equilateral triangle is deleted from this area of OAB to find out the area of OABX, right? So there above FC there are 3 equilateral triangles. Out of that, one is not counted, we will not be counting, so remaining is 2, right? Now area of hexagon will be 6 units, area of OABX will be 2 units, so the ratio is what? 3:1. Okay, in the previous case we found out the area of this rectangle from here, so that was actually instead of 2 that was 4, because this portion is equal to this portion, right? So without much paperwork or any paperwork, you can solve this sort of problems where you have to find out the ratio of areas very simply in less than 30 seconds. Okay, now let's try this problem. Here triangle OBC is an isosceles triangle. Angle ACD is equal to B. ACD, this is angle B, and AOD is equal to A. AOD, that's A, right? And A is equal to KB. Precisely, we have to find out the ratio of A is to B. Okay? Now, this here it is OBC is an isosceles triangle. That means this length is equal to this length, right? So if this angle is B, this will also be B, right? Now OA is also equal to OB. Both of them are radius. So this angle will be equal to this angle. I suppose it is Z, and it is also Z, right? Now see here. Here Z is the exterior angle for triangle BCO. So Z should be equal to B plus B, right? So Z is equal to 2B. And apart from that, in triangle OAB, Z plus Z must be equal to A plus B. So A plus B is 2Z and Z is equal to 2B. So A plus B is equal to actually 4B. That means A is equal to 3B, or A is equal to KB. That means K is 3. Right? Very simply, this problem can be solved. So friends, I hope you might have enjoyed this session. In the next session, we'll be taking more problems based on geometry. Even you must be attending other workshops also on the number system, on the permutation combinations, and all of them as well, right? Now, all of these sessions, I'm sure they will be really useful for you to understand the concept on the problems based on geometry, number system, quantitative aptitude, in fact. So you should attend all of these sessions at least 2 times. So all the concepts that we have discussed in the workshop will be cleared in your mind once for all. Okay. So if at all twisted problems are asked in the examination, then also you'll be able to solve them efficiently, effectively in less amount of time. Okay. So I'll see you in the next session once again. Bye bye.